Today I'm going to talk about the .NET framework called NServiceBus. I'm going to speak about the distributed systems theory a bit, and then pepper it with some practical hands-on examples built with NServiceBus. Then we're going to have a questions session where I will try to answer all of your questions. And in the very end, there's a small surprise waiting for you. So bear with me no matter how boring the presentation will go. So before we start, let me introduce myself. My name is Boris Tveritnev, and I work here at Xing at Payments and Billing team. I'm also a systems architect behind the Kaspersky Protection Center online platform. This platform allows Kaspersky Online users to connect their devices and to manage the security, the subscriptions, the applications and services that they purchase with this platform. The platform currently serves 2.5 million of active users with more than 4 million of devices connected. And I chose NServiceBus as the building foundation of a messaging backbone that connected various company core services that existed before the platform with security services that were developed for this particular platform in a global distributed system. And probably worth mentioning, I'm an advanced distributed systems course design alumnus, which is run by Udi Dahan. Now, Udi Dahan is the brain behind NServiceBus. And NServiceBus is a messaging patterns and workflow library which come as a part of a particular service platform delivered by a particular software company. Naturally, NServiceBus is the very heart of this platform. But apart from NServiceBus, it also includes some state-of-the-art instruments that make distributed systems design and operations a breeze. So it includes the service matrix, a modeling and design tool, which we are going to use throughout the hands-on sessions. It includes a delightful instrument called Service Insight, which allows you to look into your messaging-based systems in the runtime and discover the messaging workflow to see the messages going through the system in the runtime. And if you have ever worked with messaging, you know that it's pretty much pain in the ass to debug, because basically you're left alone with your favorite text editor parsing logs. And it also includes a service pulse production monitoring tool. Now, as the name implies, NServiceBus is an enterprise service bus for .NET. If you have ever worked with enterprise service buses or read books about it, you're probably concerned that it's pretty much about integration. Well, to cut the long story short, it's not. Following is a definition of a service bus. And some say that it has to be read and spelled for like dozens of times until it finally strikes you. And I'll make sure that you'll hear this more than one time today. So what is Service Bus? It's all in the message. So you can forget about remote method invocations, pub subbing events. Down on the wire, it's all just messages. And the trick is to think about your system as components exchanging messages, but on the higher application level. Asynchronous messaging over queues. Once you have packaged everything into this message, that message can be dynamically routed anywhere, and so can its responses. The application does not bind against any specific endpoints. It just drops the message addressed to some logical recipient, and infrastructure makes sure that this message get delivered to this logical recipient, even if they change physical locations. And this infrastructure is what makes the bus architectural style between your distributed system components. Doesn't it remind you of anything? Doesn't it sound like a definition of Ethernet? A completely decentralized middleware connecting various counterparts in distributed system. So this is pretty much Ethernet on application level. And the bus concept requires no central coordinator or broker. There's basically no physical bus in your network topology in the center. This infrastructure runs in process inside of your applications. But that's all theory, that's all good, but what NServiceBus provides us in practice is a number of messaging patterns that it allows us to easily employ in our applications. So NServiceBus allows you to establish a publish-subscribe message exchange pattern. It allows you to build your long-running stateful processes driven by messages. It allows your clients to send messages while the servers are offline. Allows to deduct and reprocess poisonous messages. It allows you to persist subscriptions, which are basically intention in the publish-subscribe message exchange, and to have them survive restarts, service restarts. It allows you polymorphically dispatch your messages, which we are going to talk about shortly. And it also allows you to have your messaging systems, distributed systems, to be unit tested, driven by messages. You can implement all of those patterns over the popular queuing technologies such as Microsoft Message Queue, SQL Server Service Broker, over the MQP brokers, despite they are a central component, and over the cloud queues such as Azure Queue, Amazon Simple Queue Service, and many other transports which are supported by a community. Now, what makes NServiceBus so different from other technologies is the principles that it's built on. So this messaging transport, queued messaging transport, is not just an implementation detail, but a primary architectural concept. If we compare NServiceBus to RPC technologies like WCF, for instance, we're going to see that they are not enforce the message queuing paradigm. And it's quite easy to start up with something following RPC techniques and have something run quickly, but that's where the problem starts. Now, this is an example of what your distributed system can turn into following the layered web services approach, provided you have enough time and resources to work on it. The problem is that RPC inherently hinders failover and scaling capabilities of systems, because they are pretty much ignorant of distributed system policies. And while that WCF does not enforce users of this technology to follow this path, it doesn't prevent them from doing either. And NServiceBus steers us away from this kind of problems from the very beginning. Now, I don't want you to look to this slide for too long. So let's consider some real-life examples of problems that you might face in distributed systems. For example, our code updates values in several tables in one transaction. This transaction acquires locks. And under a certain load, system starts experiencing deadlocks on those tables. Another kind of problems could be our order processing system sporadically failing on either database calls or some external system calls. Now the transaction rolls back, the state is erased, but users never retry in fear of double charge. The business essentially loses money. And you could probably come up with some of the problems yourself. So how does NServiceBus steer us away from them? Let's consider the service bus definition once again and concentrate on the messaging part of it. So it's all in the message. You can forget about remote method invocations, pub sub-in events. Down on the wire, it's just messages. And the trick is to think of your systems as components exchanging messages on the application level. So once you have packaged everything into the message, that message can be dynamically routed anywhere, and so can its responses. So synchronous messaging over queues is the key ingredient to distributed systems. And NServiceBus employs two types of messages, which it uses to establish two significantly different message exchange patterns. The first type is a command message, which is basically which is used to establish a request-response sort of style of communication. The second type of messages are the event messages, and they are the bricks of a publish-subscribe message exchange. So, command message is a request from a client to a server to perform some action. In order to request anything from a component, the client has to know the capabilities of that component. The client has to know how to find that component, and that couples them significantly. In a nutshell, this is very much the same as RPC, yet there's no blocking call until the end of operation. And that brings us to the concept of eventual consistency, which says that in a distributed system built with asynchronous messaging, state may not be entirely consistent at every single moment in time, but will eventually be. And as CAP theorem says, you can't have consistency, availability, and partition tolerance at the same time in one distributed system. And NServiceBus opts for availability and partition tolerance, sacrificing consistency for a short period of time, provided it has some certain reliability guarantees delivered by a queuing messaging transport. So without further ado, let's switch to our first example. We're going to build an online website with a payments component. So now this theme is very dear to my heart. I love earn money for taking money. I could probably consider a career in collector's agency, say Moscow and Casa, for instance. Just a second. That's too big. Full screen. Yeah, that's it. So what we see here is a solution with a number of projects. On the right side is a familiar Solution Explorer pane, and what you see on the left side is a panels that in Service Matrix plug into the Visual Studio. This is a design Service Matrix canvas where you can plot your distributed systems and establish a messaging workflow exchange patterns. Now I have to admit I'm not a big fan of drag and drop tools. And frankly, you don't need Service Matrix to work within NServiceBus because you can configure everything manually. I actually used to work to do this kind of configuration by hands always. Yet it has one undisputable benefit, and it makes your services a first-class entity in your solutions. Because if you look into the Solution Explorer, it's pretty hard to tell what kind of services do we have here. It's a video conference we have established to record the session. Yeah, so services. In service-oriented architecture, the service is never equal to a single web service endpoint. It is not. The service is a whole set of components that implement a business functionality, be it front-end controllers, message handlers, controllers from your back-end application. All of those components form the service. And service matrix allows you to have this service-oriented centric point of view to your system. So what we have here is a single payment service, which consists of several components. The one that is hosted inside ASP.NET MVC application, sending an order, a place order command to an order processor component, to an order processor endpoint, which is our backend, with a handler of this message. If I run the solution, you're going to see several console applications popping up, as well as a dummy website, which was configured for me by Service Matrix to be able to test messaging. So imagine for a second that this is our user interface where they submit their orders. They select a product, they select the duration, they enter their payments details, and then submit an order to us. So what happens is our ASP.NET application gets this request and immediately creates a message, drops this message to the infrastructure, and that's it. And this is pretty much it to the web request processing. Afterwards, this message is picked up by this order processor component and processed in the background. So if I send several messages in a sequence, we're going to see them all arriving to this component. Now what happens if our backend crashes, for instance? Our users have no way to tell whether our backend working or not. They continue submitting requests. So I have plenty of requests here coming in. Our ops guys running back and forward, trying to spin up the infrastructure back again. So louder. Okay. No worries. So if I spin this component back up again, you're going to see that it receiving all of those messages that our users have sent while the backend was offline. So what happens in the background, if I stop it and open the Queue Explorer, we're going to see plenty of queues created. And I have to note that I haven't touched MSMQ at all, myself at all. I didn't create any of those queues. Everything we have here was created by NServiceBus, because this is the infrastructure part that takes care of all the nasty details. So we have a number of queues per endpoint. The first one is an input queue, which holds all the messages addressed to this endpoint. Whenever endpoint is offline, the messages stay in this queue until it spins back up. We have other queues with suffixes like retries, timeouts, and timeout dispatcher, which are used for some advanced techniques we're going to talk about shortly. It also creates so-called arrow queues, which are basically a dead letter queue to hold poisonous messages. And audit queues to collect all the messages from the endpoint to form a natural audit trail of things going on in the system. So if I switch back to the application and open this order processor, for instance, you may notice that the type of a project is set to be a class library, But whenever I start the application, the console pops up. This happens due to the NServiceBus host application configured to start up whenever I run this component from the Visual Studio. Now what this NServiceBus host does is it performs a runtime assembly scan, seeking for all of those types it knows about in the assemblies, and give them a go, depending on what type it has discovered. So, for instance, there's an endpoint config class in our endpoint, which implements I configure this endpoint as a server marker interfaces. So whenever host application makes an assembly scan, it discovers this I configure this endpoint and give it a go at the bootstrap to customize the bus configuration. So what we have here is we say that whenever the bug is attached, we have to use a memory persistence engine. We could plug other persistence engines supported by NServiceBus here, as well as configure it in many, many other ways. Say, for instance, we could say that we'd like to have our service bus started with another dependency injection container and artifact container, which is the default one here. Blah, 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 blah. So this is one of the extents. Oh yeah, sorry. Is that better? Probably not. Is that better? All right. So it also generates the infrastructure code for us, with the most important part being a configuration. So if I open a configuration of our web component, okay, it's in infrastructure folder, generated code config. So we're going to find this, for instance, this unicast bus config, which is basically a static mapping table between messages sent by this endpoint and the logical recipients that those messages are addressed to. Let's open the service matrix canvas once again and demonstrate how easy it is to send another command. So if we have this order processor, which is tasked with contract creation. It creates a record that the user and the company has some sort of legal obligations between each other. And now we would like to take some money from user for this contract. So this component is about to send another command to the second component. Create invoice command. Yes, thank you very much. So service matrix is smart enough to recognize that I'm going to send the message from the endpoint and generates a code for me and even opens the file. So this component is going to integrate a payment service provider into our system. And we're going to host it in a payment gateway endpoint. 2 clicks, 1 Control-V, and that's pretty much it. We've got our payments provider integrated. So what's going to happen is whenever an order processor gets a message and processes this, it sends another message in its turn and addresses it to a payments gateway, which is to call the payment service provider to make an actual payment, either to create an invoice or to charge the bank account. It depends on the payments method the user has configured. So let's run it up. And yeah, keep your eyes on this chap here. No, we have two consoles, because I had this console prepared, yet it served no purpose. It had no components hosted in. So now if I send another message, if I create another order from our web application, we're going to see that this payment gateway is going to receive the message as well. So whenever I send a command from a user interface application, all of those backend systems are interconnected via queues with each other. So we can glance into the system in the runtime and see what's going on there using the service insight instrument. So what we see here is that our UI component, I don't know if you see it, it's not very big here. Our UI component has sent a place order command message to the order processor. We can open up this message. We can go through all the headers that were attached to this message. We can inspect the body of this message. We can even read logs of hosting endpoints. Moreover, we can plot the message exchange that happens in the real time on this sequence diagram. Now, this is something really outstanding, I have to admit, because before this tool, you would have to imagine all this communication in your head, going through different log files. What do you mean? How does it figure out which message was sent by who and... Yeah. Yeah. Yeah, so they have some kind of correlation established between them. And there's a session identifier, which is basically goes through the whole sequence. All right, so I would like to talk a little bit about messages. So all of the messages sent by NServiceBus are persistent by default. That means that whenever a queue in transport acknowledges that it has received a message, it's going to flash that on hard disk. And despite what happens in the process of message transfer between queues, or if the handling endpoint fails during the processing, that message will not be lost, even if the server goes down completely. After we bring the server back up, this message can be recovered and reprocessed. Yet, you can mark your messages with express attribute, which basically says to NServiceBus and underlying queue in transport that the message should not be persisted on disk. Well, you have to have a very good reason to do so, because this persistent mode is the default safe mode and NServiceBus comes with. It certainly has a burden of storing flushing the data on disk. However, in majority of cases, the performance that you get with this default persistent mode is good enough for, like, I don't know, 90% of cases. Yet there are messages that are naturally not subject of a very, I don't know, that they do not require to persist them, because they will not change the state of a system significantly. For instance, that might be some kind of notification messages, updating some unimportant statuses, which we basically use to, I don't know, send push messages to users. Nothing really disastrous will happen if we lose this message. And therefore, we can mark those messages as express and gain the higher performance. what happens if message delivered? Well, it remains in a queue. However, if we mark this as an express with express attribute, it will not be stored on disk, so it will be stored in memory by this messaging service. If the service goes down, the message is erased. That's it. That's the difference. Whenever they are delivered, a client acknowledges to the queue that the message is okay to be removed from the top of a queue. So the you can forward the messages that you have successfully processed to another queue. This is a part of configuration I can show you up a little bit later. There's another thing you can do with your messages. So you can tell your queuing service, queuing transport, that you do not care about messages that are older than a certain amount of time. Say your system keeps certain information up to date, which is generated on a periodic basis. If the service goes down for a while and was offline more than the period of time between those messages, wouldn't make any sense to process those old messages, because you don't care about the history, you only care about the current value. So you can mark your messages with time to be received attribute, and whenever message expires, it is removed from the queue. Okay. So this is the transport config. No. Okay, yeah, this is called audit config. So you configure a queue which is going to receive all the messages that you have processed. So whenever the message was processed, it is forwarded to that queue. You can do whatever you want with them. You can feed your log management system with messages. You can write plain log files. Totally up to you. So I would like to talk a little bit about the error handling strategies. So NServiceBus has two different poisonous messaging handling strategies. The first one, called first level retrace policies, deals with so-called transient errors. Those are the errors that are not expected to last for a long time. Say a network infrastructure hiccup. Message, whenever you try to do something, the infrastructure replied with 503. The message, your handler basically blows up. It says, I can't process it. The transaction is rolled back, and the message is put back to the top of a queue. Then it picks this message back up again in a new transaction and tries to reprocess it in a hope that the problem has resolved itself. And it does so for configured amount of attempts. It does so immediately. So it doesn't wait for anything in between the retries. So let's simulate this situation and raise an exception in our payments endpoint, payments gateway endpoint. If I run this up, wait for website to be started. We have a surprise in the end, remember? Don't go away. Yeah, so now if I send create order request, it's going to be processed by this order component, but our payments gateway will fail due to some infrastructure error. And it does several attempts immediate attempts to reprocess the message, 1, 2, because the default number of attempts was configured to 2. And then transfer this message to the upstream error handling policy, which is called second level retry policy. This policy tries to reprocess first of all, it moves the message from the top of a queue to another queue called retries. And it remembers a timeout to reprocess this message with. And every subsequent attempt will be postponed with an increasing timeout, which is basically an exponential backoff. So we have our payment gateway configured with max retries of 2, means that it tries to reprocess the message immediately twice, and then transfers it to the second level retry policy, which does 2 subsequent attempts as well, with time increase of 10 seconds. That means that between the first failure and the first retry, it's going to wait for 10 seconds. It's going to wait for 20 seconds between the first retry and second retry, and so on, exponentially increasing the timeout, allowing you to deal with more persistent kind of errors. An example of such error might be our payment service provider that runs some batch jobs in the background in certain time frames, and they are not available for updates in those time frames. So our first level retry policy would not allow us to handle this kind of errors in a graceful manner, because the message, the failing message, would stay on the top of a queue and block the whole queue. The message would pile up, and this one single message would block it. The second level retry policy deals with those kind of errors. Yep, and that's pretty much it to the first example. Let's switch over to our presentation. Come on, wake up. Right. So we have accepted eventual consistency, and we may benefit from publish, subscribe, exchange, message exchange button. But before doing so, I'd like us to come back to the service bus definition once again and concentrate on the routing part. So, which says that once you have packaged all the information needed for processing into the message, that message can be dynamically routed anywhere, and so can its responses. Our application does not bind against any specific endpoints. It just drops the message, as you have seen in the example with order processor. So we just sent a message. We didn't specify an address queue. We didn't specify any names. This is the infrastructure that makes sure that messages get delivered to those logical recipients, even if they change their physical locations. And this infrastructure is what brings the bus architectural style between your distributed system components. So publish subscribe is the message exchange button, which is built with event messages. And this type of messages is very different to command messages. So a command message can be sent by as many clients as needed, whereas an event message is generated by a single logical authority. There can be many authorities publishing banana prices in your distributed system. There's only one single logical authority that raises the event. A command message is delivered to a single service recipient, whereas a copy of an event message is delivered to dozens or hundreds of subscribers, or to none, if nobody has subscribed for them. Event message is basically a notification of a fact that happened in your system in the past and cannot be undone anymore. And that gives us the power of decoupling the components significantly. Most often than not, those components belong to different services. And one of the service-oriented architecture pillars says that services are autonomous, and publish subscribe is the tool that allows us to guarantee the autonomy of our services, because neither a subscriber nor a publisher know much about each other. The subscriber just raises the message, the event. Subscribers get those events and do whatever they want to do with it. Okay, so let's talk about polymorphic dispatch and routing features shortly. So if you happen to develop and maintain a web service for a long time, you probably have had to deal with versioning. Versioning those kind of APIs is no fun. It is quite easy to add a new method to your interfaces, to your web services interfaces. But what happens if your business asks you to extend a process that you already have and ask you to add some other parameters to the do something special method? Most often, desperately, we're going to create a do something special to method. Yeah. And the old methods, chances are that those old methods will never be cleaned up from the interface, because often there's no way to guarantee that our clients have switched over to this new endpoint. Over time, this API, those old methods, those remainders, will build up and result in a messy API, which is really hard to decipher and to maintain, especially for the newcomers. And NServiceBus deals with versioning of API, which is the messages that your component send and publish, through inheritance. Imagine you have an order, a user-created event, and now your some department whose services has subscribed to this message ask you to extend this message with some kind of datestamp property. What you do is you create a new event, user-created extended, inherit it from the old type, add the properties that you need. Then you update your publisher to publish this new type of event instead of the old one. And at this point of time, none of your subscribers know anything about this new type of event. They have subscribed to the old type, but the publisher publishes the new type of event already. All of those old subscribers will receive their messages, because thanks to the polymorphic dispatch feature NServiceBus comes with. But there's more you can do with it. And imagine your business have different concerns that are tied to a certain event. For instance, we had a user-created event, and our marketing department started making some online advertisement campaigns, and we get users coming from those campaigns. Every campaign action should result in some kind of campaign activity occurred event. And now we would like to extend our processes which handle the user-created events with the information from this particular campaign-related concern. What we do is we inherit this new event. We can call it user-created from campaign, for instance, from both, from the old one, from user-created, and from campaign activity occurred. We can do so because NServiceBus allows you to define your messages as interfaces. And therefore, we can benefit from multiple inheritance. Now we publish this new event, and what we have to do is to create a new handler which deals with only that small campaign-related concern. It subscribes to the campaign activity occurred event, and it gets it thanks to the polymorphic routing feature, which would be probably almost impossible to get with RPC-style technologies. And before we switch to the second example, I would like to talk about the all-important concept of long-running processes, because this introduction would not be complete without them. So these processes are all around us. Consider a retailer who can't ship a product until the credit card has been charged. It cannot ship it either if the user has cancelled the order in the meanwhile. That's a long-running process. Another example is a customer who has to spend a certain amount of money before he attains a preferred customer status. A premium membership is in effect as long as all invoices were paid in time and the runtime is not over. Usually this kind of long-running processes are controlled by ugly batch jobs. There's a number of problems with these jobs that NServiceBus elegantly solves with message-driven real-time processes called sagas. The term comes from a study published by Cornell University, where the authors suggested to break the long-lived transactions into a sequence of reversible steps. And that's pretty much what saga is. In the messaging parlance, the definition of saga would be the process whose execution lifetime exceeds the time necessary to process a single external event. It processes a stream of external events, and therefore it has to be stateful. Long-running means it's stateful. And then NServiceBus provides us with facilities to manage the state and to encapsulate the business logic that handles the transition between steps. A community have established a number of patents around the Saga application with two main ones. The first one is a controller that actively manages some business related process activity. For instance, you might have a user registration saga in your system. This saga involves several steps to be handled. The first one is profile creation, then generating a confirmation link, sending the email to the user. The last one being the confirmation request handling. An observer pattern is a process which passively sits in your system and listens to external events and coordinating some activity. Now, an example of such a process might be a customer who attains a preferred status after spending a certain amount of money. And you can always mix and match these patterns in order to satisfy the needs of your particular system. So let's switch to our example number 2 and see the pub sub and long-running sagas, processes, sagas in action. Let me close this one. Now, if you remember, we have a website which allows users to submit their orders. We even take money from users, but we provide no service. Well, this is a very good business model, yet I have to admit that probably it wouldn't last long. And at least it's unheard of, with one small exception being crowdfunding platforms, where people deliberately give away their money for stuff they will never get. At least I never got my beacons. Luckily, we have a system which provides users with premium features. And naturally, we have a premium membership service over here. As you remember, publish subscribe is the tool that allows us to decouple components. And so the least information shared between the services is the event. Is the event that payment service component called place order command handler publishes. So it publishes a contract created event, which is, I think I messed it up a bit. Okay, never mind. So we publish a contract created event, which is handled by a membership processor component, which sends out terms of usage to users whenever the contract is created. And we have another accounting component over here. I will add a subscriber right now, which which does accounting, basically. So over here, contract created, event handler, deploy components to accounting processor. Okay, so I have this contract created extended event here as well to demonstrate the polymorphic dispatch features. Let's build a solution. So what's going to happen right now is we're going to send a familiar place order command. This command will be handled by an order processor. It will send the create invoice command as well as publish a message that the contract has been created. There are two components here that have subscribed to this event, and they all are going to receive this event eventually. This is an eventual consistent Visual Studio. Come on. Yeah. Never mind the error. Just give me a second, guys. Yep. Premium membership, which is halted for some reason. Okay, so 2 subscribers over here. The website is over here. So we're gonna submit a request, an order request, which you probably remember. Yep. And these 2 processes have received a contract created event. So what happens in the background? Yeah, sorry. So what happens in the background whenever those components subscribe into events start up, they send a subscription intention command message to the publishing components. Those components gather those subscription intents and store them in their configured persistent storages. As long as we run this in the basic debug mode, it's all stored in memory. However, if you configure a persistent storage behind the your components, those subscription intents will be stored reliably and will survive restarts. So our accounting and membership have subscribed to this order created event, which is specified in their unicast bus config, which says that the message membership processor endpoint would like to subscribe to contract created event from the endpoint example to order processor. Now this is a dynamic configuration, and this is a dynamic routing, because before the start, order processor knew nothing about those subscribers out there interested in this message. They have started, sent the intent, and now order processor knows that it has to deliver those events to those components. We can see this plotted in the service insight nicely. So our order processor component handling the message place order command sends a create invoice message as well as raises an event message which is delivered to these 2 endpoints. Now let's switch to the polymorphic dispatch example. Say our accounting department have requested an additional date time field in our order contract created event. What we do is we create this contract created extended event Where are you? It's supposed to be over here. Yeah, it's not. Right, so let's delete it. Yeah, we can do this manually. Yep. So this is our contract created extended event, which holds the datetime property necessarily to do for accounting department to do their stuff. We go to order processor and we teach our place order command to send this extended event. None of the endpoints has yet subscribed to it. At least they shouldn't. Let's check it out. Yeah, sorry. So I'm going to check if those components have subscribed to this event so far. Comment this one out. Build a solution. So what has changed is our order processor endpoint now going to publish the new type of event, an extended one with properties that were not in the original event. Our subscribers, in the meanwhile, have not subscribed to this event yet. So we basically upgrade our system step by step, and we don't bring it down as a whole. Yes. Set up. Okay. You can mark the old type with those type properties with those attributes, and you can handle those attributes in your new handlers. However, there's no such thing that enforces endpoints not to use parts of the messages in the NServiceBus. So yeah, we published the new type of event, yet we have subscribed to an old one, and still we receive those messages published. Now if I stop this, and create a message, what? A mapping for the new type of event here. Contract created extended event. Make sure that we have a handler for this event as well, because otherwise we're going to get an error. That's contract created extended event handler. Standard event. Yeah, like so. So, and we're going to make use of those new properties arrived with this new type of event here. So we're going to say that we have received a date, which is a date property of a message. Where are you? Okay, so let's build this up and hopefully it works. That's not. Oh, it's supposed to be public. Oh yeah, that's an old type of event, sorry, yeah. Yeah, sorry for the pause. I can only remind you that we have a surprise in the end. Yeah, so I'm going to run this one up again. Hopefully it's successful. Yeah. So now we expect our accounting processor to get 2 messages, even though we have sent only one with a new type of event. Now, this polymorphic dispatch allows you to have both the old version and the new version of your endpoints and components at the same time in your system. And you can perform some kind of experiments on the live system reliably and securely, as long as the new component that subscribes to this new event does not deal with the operational database that you work with. You can, for instance, test the new persistence storage that you would like to use in the new updated system, in the new version of the system. So unfortunately, that didn't work out as I expected. Probably, no. So the mirror didn't happen. Unfortunately, I have broke this example while preparing to it, so I guess you would have to believe me. There's another component there. It's not partial. Maybe that's the problem. Let me try it once again, and I will not bother you with this example anymore. So, well, for some reason it sends only one subscription intent, and I guess we're not going to see it in work. No. Okay, it's a pity, but no. All right, now let's go to the saga and demonstrate what you can do with this NServiceBus feature. So we have a membership processor which hosts membership service, premium membership service components in. Those components implement the premium membership, which is a long-running process that involves several state transitions. So now a simple example, we're going to have our customers either basic or premium, which is implemented by this membership saga instance. So what it does, it subscribes to several events, order-placed event, and invoice sent and encashment event. And it applies logic according to its current state and the facts in the system that has happened in other services of our distributed platform. We can call it platform already. We have 4 services here. So this long-running object obviously have a state. And this state is consists of your application-related data. We hold a user identifier to reference users and events and the state of their membership with. And we hold a Boolean property whether the user is currently premium or not. Other properties are related to the way that NServiceBus records state transitions and remembers who sent what to this saga. So Saga has a unique identifier, and we can configure the mapping between the messages that are Saga license and a particular Saga instance by configure this mapping from event properties to the Saga properties, Saga data properties. In our case, we're going to reference the Saga with this user ID identifier. So the Saga instance and this data is going to be persisted between messages arriving from the system, from the platform. Whenever the message arrives, the endpoint uses this mapping to look up the Saga instance in the database. If it fails to find one, it uses some knowledge that we provide with our membership, with our Saga instances, using this kind of marker interfaces. So in this particular example, we say that we want our Saga instances to be started whenever an order placed event arrives. And it also handles invoice sent and encashment event, which could also instantiate a new Saga instance in reality, actually, because you never have to rely on certain message order arrival, because this is impossible in message-based systems. You cannot imply a certain message order arrival. But in real life, invoice sent and encashment, always after a significant amount of time, say like after 3 weeks of waiting for a user to transfer money. So it's pretty, it would be pretty accurate to set the real Saga up with this kind of configuration. So let's go to the order processor and tell it to publish order placed event. Note the resemblance between the event and a command. It is quite often to have related event and a mirrored related command and a mirrored event in your systems. So if I build this up, now we're going to keep our eyes on this membership processor component. So whenever the order is placed and processed by an order processor component, it's going to raise a order placed event. Our Saga instance, which does not exist by this moment at all, but there's a subscription existing already, will be created by this message arriving to the endpoint. There you go. So premium membership have received an order placed event, and it has applied a logic, a business logic, according to the state that it was currently in. So the initial state that the user was basic, and whenever this message arrives, Saga remembers that the user is premium from now on. Yeah, this is over here in this membership Saga instance. So let me increase this a little bit. We have this code over here. So this is the code that handles the order placed event. It remembers the user ID right with the message, and it also records that the user is premium from now on. It is all done in single transaction. And the message queuing transport, as well as your persistent storage, all participate in this already distributed transaction. So whenever it happens, if something goes wrong, the message is back in the queue. The state is as it was before, so it remains consistent until you process that message successfully. Okay, as Sagas are long-running processes, they have to have a way to deal with the time dimension. And NServiceBus provides us with tools to deal with it in the same reliable and message-driven manner. So our Saga here in the simplest case that we have here, knows the duration of of membership by default, and it requests the infrastructure to inform this very same particular instance of Saga, to inform that the membership has expired after 10 seconds. And we can see it over here. So whenever the message arrives, we process it, we turn our user to premium, we subscribe to this timeout, and eventually, after waiting for 10 seconds, the Saga does not exist in this time. This particular instance is stored in the persistent storage. It's not in memory anymore. But whenever the timeout expires, this membership expired timeout message is sent to the very same endpoint. We can see it over here in Service Insight. So, thank you very much. You're so helpful. So this is our Saga instance. This is the message that has created the Saga, and this is a membership expired timeout message. We can see it plotted over here. So this is a membership processor, which got the order placed event first, and then it has a membership expired timeout received. Now let's extend this example and complicate the workflow a little bit. So now, whenever the membership started, we're waiting for a successful invoice payment. If the invoice was not paid in time, the payment gateway component is going to publish an event that it has received a notification from our payment service provider that a certain invoice belonging to a certain user was sent in encashment. As long as our Saga instance has subscribed to this message, it's going to receive that one and apply a logic on top of that. So if you remember, we had our membership lasting for 10 seconds. The payment gateway component on its turn is going to publish invoice sent in encashment event after 5 seconds. Come on. Yeah, so let's create an invoice and see our user going through all the state transitions in this long-running process. So it became premium after we created an invoice. But eventually, after 5 seconds, the invoice was sent in encashment. And we have applied a logic according to the actual state and the information that arrived with this message. So whenever the message invoice sent in encashment arrives, we first check if the user is still premium. If the user is premium, we mark him as basic. We don't want our non-payers to get premium services anymore. And we can apply some other logic on top of this. We can send them a reminder, we can send police to their house, anything, through the messaging as well. We can send a command to other components to do stuff. Or we can raise the message, an event message, that the membership state has changed. And other components in our distributed system can make use of that information as well. That's pretty much it. This is where I'd like to stop. Yeah, just a second. It will wake up after 5 seconds, I guess. Oh, come on. No? All right, so NServiceBus is a service buttons and workflow library designed, yay, around distributed systems fallacies. It makes you very much aware of them, and it gives you instruments to work around them by not ignoring them, but take measures against them. And it takes care of all the infrastructure details necessary for that, and allow you to put your focus into the business concerns, the place where it belongs to, taking the burden of managing the infrastructure away. It simplifies the development of scalable distributed systems, because you have seen it allows you to implement very simple and very straightforward components that handle messages. It reduces the cost of development and maintenance of systems, as it provides you with lots of instruments around it. And it also has some more cookies, which we didn't talk about at all. I will shortly mention them, because we didn't talk about extensibility points. And NServiceBus allows you to extend it pretty much in every direction you can imagine. You can plug your own dependency injection frameworks. You can plug your own login infrastructure. You can even plug into the message handling pipelines and mutate messages in runtime, and many other extensibility points. It provides you with instruments to monitor and administer systems in runtime, as well as ensure the security of message exchange between your endpoints. It provides you with scale-out features and failover features we didn't talk about yet at all. And many other topics you can find information about on particular .NET website. They have pretty